Alrighty guys, so in today's lecture what we're going to be learning how to do is we're going to be taking these skeletal structures, these things that we learned how to draw last time, and what we're going to do is basically go backwards. We're going to take this and using the information that's found in these skeletal structures, we're going to learn how to write the chemical formula for all of these structures. Okay, so just to review one quick thing we talked about, we learned last time that in these corners basically represent carbon and all the hydrogens connected to it. Okay, so carbon and hydrogen. And so each of these corners that don't have anything drawn on them, they're basically carbon and hydrogen. Now the number of hydrogen is going to vary depending on what type of corner it is, but we know that these corners all have carbon and hydrogen. We know that this corner is not carbon and hydrogen because there's a Br at the end of it, right? And so this corner is just occupied by Br. That means there's no carbon and no hydrogen there. Okay, so just based on the information that we have, we already know that there's going to be a Br in this molecule, and we also know, since there's three corners, right, 1, 2, 3, that there's going to be 3 carbons. Okay, so there are 3 carbons because there are 3 corners, and we know that there's a Br. Now, the issue, I guess the hardest part, is figuring out how many hydrogens are on each of these corners. Okay, now it's actually very easy. There's a very simple rule that we can use. If you think back to what we learned in the last unit, we learned about something called the Octet Rule. Okay, we learned that the Octet Rule is that all, I guess, carbons and all elements other than the exceptions that we talked about. So that means that carbon, it needs to have 8 valence electrons, right? Hopefully that rings a bell. Now, carbon needs 8 valence electrons. What that means is we know that each bond, right, each of these lines is going to be 2 valence electrons. So if carbon needs 8 valence electrons, that means it needs 4 bonds. Okay, so Octet Rule tells us that carbon needs 8 valence electrons, which we can translate to carbon needing 4 bonds. So we know that there's a carbon right here, right? So if we draw the carbon, we can see that there's a connection between this carbon and another carbon right here. We know that this is a carbon as well. Now, if you notice, this is a single bond. So this carbon right here has a single bond, but we know carbon has to have 4 bonds. What that means is, since this carbon has 1 bond with this carbon right here, that means that this carbon needs 4 total. So we need to add 3 hydrogens. And the reason why we do that is because carbon needs 4 bonds. This carbon has 1 bond to the carbon. That means in order to make sure it's following the octet rule, it has 3 bonds to the hydrogen. That way it has 1, 2, 3, 4 bonds, or 8 valence electrons. Okay, so we have 3 hydrogens on this carbon. Now if you take a look at this carbon has a single bond here with the carbon we just talked about. And then right here, it has another single bond. So that means that this carbon has 2 bonds. Well, we know that carbon needs 4. So if I have 2, that means this carbon must have 2. It must have 2 hydrogens. And again, I know that because it has 2 lines, 2 bonds. And so it needs 4. So we would just add 2 more. So there's 2 hydrogens that we just added. And lastly, this is a carbon as well, since it's a corner. It seems like similar to this one right here, it has 2 single bonds, right? 1 single bond with this carbon, 1 single bond with this bromine. And since it has 2 bonds and carbon needs 4, that means that this carbon also has 2. Okay, that way it has 1, 2, 3, 4. And so we can count up how many hydrogens we have total now. We have 1, 2, 3, 4, 5, 6, 7. We have 7 hydrogens. So what we did is we figured out how many of each element we have in this molecule just using the skeletal structure. Now we're going to write the chemical formula for this molecule, and you always want to start with the carbons. So 3 carbons, so it's C3, and then you want to do the hydrogens. So you want to do the carbons first, and then the hydrogen second, so H7, and then whatever else last. so Br. So this would be the chemical formula for this molecule. Now, I do want to mention there is another way to do this, and I think this is a better way to do it, but either of these answers will be acceptable. But what we can do is we can start with this carbon on the left, right? It's C and 3 H's, so we can do CH3, and then with the next carbon is CH2, and then the next carbon is CH2, and then we have lastly Br. Okay, so either of these answers will be acceptable. I personally think that this is a better way to do it just because it's more descriptive. But for the purpose of this class, you can do it either way, whatever is more comfortable for you. But this is the preferred method, and I'll be using this method more often. So I would say it's more in your favor if you get used to writing the chemical formula like this. Okay? Alright, so we're going to do one example. If you feel comfortable doing this on your own, feel free to do so, but I'm going to go through it step by step. So if you want to try it on your own, which I do recommend, pause the video, but otherwise you can follow along. Now, again, what we want to do is we want to draw or figure out how many carbons we have. So we know that we're going to have a carbon right here. We're going to have a carbon right here, carbon right here, carbon right here, and carbon right here. And again, every single corner is going to be a carbon. Now we know because of the octet rule that carbon needs to have 4 bonds. Okay, so if you take a look at this carbon right here, it's a little bit different from the molecule that we looked at earlier. We see that it has a double bond. So this carbon already has 2 bonds. So if it has 2 and it needs 4, how many more does it need? It needs 2 more. So it's going to have 2 hydrogens. This carbon right here has 2, right, because of the double bond, and it has a third one in the single bond. So it has 2 in this bond, 1 in this bond. So it's going to have 3 total already. So that means if it has 3 and it needs to get to 4, it just needs 1 more. So this carbon has 1 hydrogen. Next, this carbon right here has 1, 2, 3 lines because it's kind of in the middle of this of the molecule. It has 3 lines coming out of it. Since it has 3, it just needs 1 more. So this carbon has an H. Let's go down first. This carbon has a single bond, 1 line, so it needs 3 in order to get 4. And then lastly, this carbon right here has a single bond as well. So that means it's going to need 3. Okay, so we've made sure to figure out how many hydrogens each of these carbons need based on the line. So now we can just count them up. So again, there's 2 different ways to do it. The first way you can do it is by counting them all up, which I'll do later. But the method that I prefer you guys to use is just kind of go in order. Okay, so here on the left we have CH2. And then the next one we have CH. Next we have CH again. Now it doesn't matter if you go down first or to the right first. I'm just going to go down first. CH3. And then you're going to go CH3. And even if you went right, you would get the same formula. So it didn't really matter. Okay, so here you go. This is going to be the chemical formula for this molecule. The other option that you can use, the one that I don't recommend, but you can use, is by just adding up all of the atoms. So we have 1, 2, 3, 4, 5 carbons. So you can write it as C5. And then for the H's, you have 2, 3, 4, plus 3, 7, plus 3, 10. So C5, H10. So I don't recommend using this method. Again, this is the method that I prefer that you do it, but you can do it either way. Alright, so before we finish up, we're just going to review very quickly how to draw the skeletal structures if you need a little review, just because you'll have this on your assignment. And I want you guys to challenge yourselves and try a little bit more complex skeletal structures, because we will be going into really big molecules very soon, actually. So again, we have this very big old ugly structure, and all we need to do is draw the skeletal structure. So here we have a carbon and another carbon, so I'm just going to draw a line like this going down, and this is going to represent this carbon. We'll call this carbon number 1. We'll call this carbon number 2. So this is carbon number 1. This is carbon number 2. Okay. And then we're going to move on to carbon number 3. So carbon number 3 is going to be going up. And then if you notice, carbon number 3 has 3 carbons in a line connected to it going up. So I'm just going to go 1, 2, 3. Okay? So this would be, we'll call this 3A, 3B, and 3C. So here we would have 3A, 3B, and 3C. Okay? Alright, and then we're going to move on down the chain to carbon number 4. So we would draw a line going down like this, and this would be carbon number 4. Actually, that's a bad spot to put it. Carbon number 4 would be this corner. And if you notice, this carbon has some carbons going down too. So we'll go down, and this would, I guess we'll call this 4A and 4B. So this carbon would be 4A, and then we would have another carbon connected to it. So we're going to draw another corner. This would be 4B. Now, if you look at carbon 4B, it has another split, right? So what we're going to have to do is draw the split. So I'll call this carbon 4C. So we'll have a carbon 4C. Okay, let's have it go this way. This would be carbon 4C right here at the end of this line. And then we'll have this one called 4D, but 4D is coming off the split, so we'll have a split right here, 4D, and then we'll have 4E. Okay, so I'm just naming them. You don't need to name them exactly the same way that I'm naming them. I just want to make sure that you guys are able to go back and forth and see where we got these lines and these connections. And again, you don't need to go the same direction that I'm going. You just need to make sure that the correct carbons are connected to the correct carbons in the skeletal structure. So we did up to 4E, so we did everything going down right here. And then lastly, we have, I guess this carbon, we'll call it number 5. Carbon number 5 right here, connected to 4. Now carbon number 5, it's not connected to another carbon, but it has a double bond with an O. So what we're going to have to do is we're going to have to draw a double bond with an oxygen. And we have to draw the oxygen because it's not carbon, and everything that's not carbon or hydrogen connected to carbon we need to draw. So here you go. This would be your structure. Obviously, you wouldn't write 1, 2, 3, 4, 5, 4A, 4B, 4C. You would just have the lines and the oxygen, but this is basically the skeletal structure for this ugly Lewis structure. So if you guys notice, this is actually a lot easier to draw. It's a lot cleaner if we get rid of all these numbers. It's a lot cleaner and simpler to look at than the Lewis structure on the left. And this is the reason why we draw skeletal structures, because as the molecules get bigger, it starts getting a lot more cluttered because there's so many hydrogens everywhere. So this is actually a very simple way to draw this big, old, ugly Lewis structure. So hopefully that was helpful. Let me know if you guys have any questions, but good luck on your assignment, guys.